Hi guys, welcome to MCS TV. My name's Daniel Welch and I'm a teacher at Cypress Point Elementary. And today we're going to be doing a really fun science lesson. I have a question. Have you ever wanted to be a scientist before? Because I know I sure have. And that's exactly what we're going to be today. We're going to be scientists. So we're going to be talking about magnetic interactions, how magnets interact with different objects and different things. So, thinking about this, where have we seen a magnet before? You might have seen them on a refrigerator, maybe on the smartboard or the blackboard at school, and many other places. And they're really fun to play with. And that's exactly what we're going to do today. We're going to have a lot of fun with these magnets. So, what are some things that you know about magnets? Some of the things that you should have thought of is that they can attract or stick to metal objects. Anything that is silver, maybe you can stick to a magnet. We also know that two magnets stick together. We're going to actually do an experiment, and we are going to see what metals magnets attract to. Okay, so let's actually look at that right now. So right here, we have several different objects. Some that might stick to the magnet, some that might not. So let's actually go through these real quick. We have a paper clip, a bottle cap, a toothpick, some different coins like dimes and pennies. So let's see which one of these objects that magnets stick to. All right, so we're gonna wave over, and you can actually do this at home. You can go to your refrigerator and get a magnet, and you can do the same experiment that I'm doing right now. So let's scroll over and see. All right, so we're gonna put them in a pile. We know that the magnet sticks to the paper clip. Now, does anybody know why that is? Why did that magnet stick to the paper clip? And we're gonna talk about that right when we're finished. What about the bottle cap? Yeah, so the bottle cap is also a certain type of metal that it sticks to. Let's see the toothpick. No, we're gonna put that in this pile that does not stick to magnets. All right, let's see these coins. Now, we said earlier that they attract to silver or metal objects. We know pennies are metal and we know dimes are metal. Let's see what happens with the interaction between the magnet and the coins. I thought magnets attract to metal objects, and these are metal objects, but why didn't they? And the reason is because these pennies and these dimes, they don't have a material in them called iron. And that's what a magnet needs to be able to stick to another object, is iron in it. So any one of these that stuck to the magnet actually has some iron in them, okay? And that's why that they stick to the magnet. So we are actually going to do another really cool trick. And you can also do this at home, but you're going to need a magnet that kind of looks like a little donut. It's got a hole in the middle, okay? So what do you think will happen when I put these two magnets, these two round magnets on the pencil? What do you think is going to happen? So let's see. All right, so I'm gonna drop this down and I want you to notice what happens. Did you see that? Wow, why is that happening? Look at that. That is so cool. Now let's actually look at the board, and throughout this lesson, we're gonna see why this is happening. So how did it float like that? Was it magic? Am I a magician? Or was it something else? If it wasn't magic, how did we do that trick with the magnets? That's what we're going to be figuring out today. So we can see that magnets have poles. There's a south pole and a north pole on every magnet. No matter if it's a bar magnet like this, or if it's a circle magnet like this, all magnets have poles. So let's look at these poles. So this is the north pole, and this is the south pole. If we look at the bottom down here, it says that magnets have the strongest magnetic force at its poles. So the strongest amount of force is going to come out right here and right here. And it's kind of weak in the middle. And I think we just saw a word that we don't really know quite yet. And that's this word right here, magnetic force. What is that? What is a magnetic force? Let's look and see. So a magnetic force is the push or pull that a magnet exerts or that it gives off. So, like we saw in our first experiment, we saw that the magnets pulled the objects that had iron in them. And we are going to be looking at some more examples of how magnets interact with each other rather than with other objects. Just like we saw in the floating experiment. So this is what happens when two poles are close to each other and they are the same poles. So when two of the same poles, a south pole and a south pole, start to get close to each other, they do something we call repel or push apart from each other. And you can see the arrows pushing back, pushing apart from each other. So when two same poles get together, they repel. Now let's look at the opposite. This is what happens when two opposite poles come together or get close. So a south pole and a north pole on the magnet. When they get close, what do you think is going to happen? Will it repel like the other ones? Or will something new happen? What do you think? And if you said they would come together or attract, you are absolutely right. When two opposite poles come together, they attract to each other or they stick together. And this is why the magnet floated. Let's actually look at that again. So what we're going to do is we're going to have a south pole on top. And here's what the trick was. Can you guess what happened? That's right. I put the other south pole from the other magnet. And when they came close together, that's why they floated, because these two poles are facing each other and they are repelling like we just saw. They are repelling from each other. So now we're actually going to look at some more experiments to prove or to kind of show the interaction between opposite poles and the same poles. So let's come over and look at this. And these are once again some really, really easy and cool tricks that you can do at home. So for this, all I have is just a little board, and I have a little piece of paper over it. All you really need is just a piece of paper. And we're gonna see some different tricks that you can do with these magnets. And you could show off to your friends and they'd be so amazed. Whoa, look at that. Can anybody think about, how am I doing this? What's letting me be able to move it around kind of like a magic trick? And if you said because the two opposite poles are together, you're exactly right. So underneath, I have another magnet. And these two magnets are sticking together, but their magnetic force is really strong. And when you have a strong magnetic force, it can actually go through other objects. And this strong magnetic force lets me do this trick. What's going to happen when I flip this bottom magnet around? What do you think might happen? And if you said repel, you are exactly right. So let's actually look at this, and it's going to do something really, really cool. So when I put these two together, did y'all see that? I'm going to do it again. Pay close attention to this magnet and see what happens when I put the two same poles together. Whoa. Did y'all see that? It flipped over because the magnetic force is repelling it away, and then it flips over so it can attract to that same pole. How cool is that? All right, I have two more experiments just to show the interaction between the two different poles of these magnets. So let's look at another one. Once again, two different shaped magnets. Magnets can be any shape. They can be big, they can be small. And that doesn't really matter of how strong they really are. You can see that you can have a really, really small magnet that can be really strong and have a big magnetic force. So let's actually look at these two. These are really cool. And you can see, I'm going to stick these two together. I don't know which poles they are. So I want you to tell me what two poles came together. Do y'all know? What could this pole possibly be? Maybe a North Pole? And this one could even be a South Pole. They came together and attracted. Remember, they have to be what? That's right, they have to be opposite poles, okay? Let's see if we put the same poles together. Oh, what's starting to happen? You see that? How cool is that? It's actually running away from it. I can make it spin, I can make it do different tricks because the magnetic force is so strong with these two that it is pushing it away really, really hard. So let's look at I'm gonna put it on the table and we're gonna see how close they need to be to attract to each other. Did y'all see how far that was? That's a really strong magnetic force. It's pulling really hard because I didn't even have to get that close and it started moving towards it. Let's see that one more time. All right. And we have one more experiment. This one's really cool, and all you need is 2 bar magnets. You can get these online for pretty cheap, and a string. So let's look at this. And once again, we're just seeing the interaction between the different poles. So we have this one floating here, and we're going to see what happens when I put this south pole with the other south pole. So let's see what happens. Whoa, it's starting to spin. Do y'all see that? How cool. It's spinning around because it's repelling, and when it spins back around, it repels again, and it keeps pushing it more and more. So now let's put the same pole, the opposite poles together, sorry. And when we put the opposite poles, what happens? They are attracting. Some of these are actually really strong. You can see it's holding that heavy magnet up. All right. So just a quick review. We talked about magnetic force, the energy that is a push or a pull between magnets. We talked about the North Pole and the South Pole and what happens when these two interact with each other. Let's do a quick review. Do you remember what happens when a North Pole and a South Pole get close to each other? You're right, they attract. What about when the same poles come together? What happens then? Think about it real quick. What happens? They repel from each other. Awesome. I really, really hope you guys enjoyed our lesson about magnets today and being a scientist with me. Once again, my name is Daniel Welch, and I teach at Cypress Point. and I really, really hope you join us again on MCS TV. Bye.